Hello, this lesson video we'll be looking at finding the domain and range from a graph. Before we get started though, we're going to be writing our domain and range in interval notation. So let's just do a quick recap of what this is. We covered this back in Algebra 2. This is just a simple line graph with an inequality drawn on it. And interval notation is this bracket, parenthesis kind of stuff. Brackets we use when we have closed dots, and parentheses we use when we have open dots. Closed dots mean you include the number, open dots meaning we don't include it. What we're trying to do here is we're trying to make this ordered pair looking kind of thing, using these parentheses and brackets, if you will. And we work left to right, and in this case, in this graph, working left to right, I hit the endpoint first. So that's going to start my notation at -5, and because it's a closed dot, I'm going to put a bracket around that -5. And then this line just keeps going into these positive numbers. So we say that there's not really an endpoint. I don't know where else it ends in this direction, so we identify that as heading towards positive infinity. Infinity signs we should always enclose with a parenthesis. The way I remember, it's a curve here, so enclose it with a curve. That's how I remembered it in school. So if we look at another example here, this guy has 2 endpoints. So when we're thinking about the ordered pair thing, -2, if we work left to right, we usually start with the smallest number, has an open dot, so I'd put a parenthesis around -2, and 6 has a closed dot, so I would enclose it with a bracket. Now, one thing I want to mention, more or less like that first example, what if I had a number line, let's see, we've got a 1, here's -1, -2, and I have a graph that looks like this. Whoops, sorry. So it's pointing towards the negative numbers. The side of 0 that we're on, whether we're on the negative side or positive side, we can dictate by using positive infinity for being to the right of 0 or negative infinity for being to the left. So since this arrow is pointing to the left side of 0, when we start our notation, we actually want to write negative infinity, just so we know that we're coming from these negative numbers. And again, infinities always are enclosed by parentheses. And then obviously our endpoint to the right here is a 1 with a closed dot, so we would do a bracket. So just want to remind you about that. And also, what if I had this? What if I had a number line where my picture that I drew was the entire thing? What would its interval notation be? Well, we don't have any endpoints, so we're coming from this negative side, so negative infinity, and we're ending somewhere in this positive side, so that would be our interval notation for the whole number line. Okay, so the reason we looked at interval notation again is because we're doing this domain and range thing from a graph, and we're going to write domain and range in interval notation. So domain and range, you've seen it before, but it might have been a while. I like these 2 pictures. I think of domain and range as like a function, or excuse me, like a machine. The domain are the x's, the raw materials that you put into the machine. The machine is the function that does its work, and then it gives you a product at the end. It gives you an answer, and these are the range. These are the y values. So for example, let's say I pick 2 from the domain, so my raw material 2. I plug it into the function, and the machine does 2 squared, which gives me a 4, so 4 is part of the range, because that's what the function spit out. So to paraphrase, domain are the x values that we input, and the range are our y value outputs. Okay, so x's are the domain, y's are the range. So now let's kind of get into this meat and potatoes here and look at a graph. The domain are x's, so we want to think looking left to right because that's how the x-axis goes. And you've got to have some imagination. You've got to I had to take a screenshot of this graph, but you've got to understand that this graph keeps going up through the roof into the sky. Sorry, that was a bad connection there. But you've got to have an imagination here. And the x's, we've got to ask ourselves, left to right, is there an x number that I could go to and not find a place to put my finger on the graph? So for example, if x equals 1, I could put my finger here. If x equals -3, I could put it here. It goes off the picture, but I just have to know in my mind that the graph keeps going. So I could come out here to 100, and I could find, obviously it would go off the screen, but I could find a place. So we describe that as a domain that's all the x numbers, so all the real numbers. But like I said, we want to write this in interval notation. So that last example we talked about, -infinity to +infinity, all x numbers would work. The range, now, we've got to think up and down, okay? So vertically, you know, is there a y value that I couldn't find a place for my finger? So if I think about y equals 1, I have two choices. I could put my finger here on the u, or I could come and put it over here. At y equals -3, again, I have two choices. Is there a y value that I couldn't put my finger? Well, think about down here at -5. The graph doesn't go down there, so I could not put my finger there. So I've got to show that there's only a certain interval that these y values occur. So I find either a high or a low point, and I've got this low point at -4. And since my graph is on it, I'm going to enclose it with a bracket. So at -4 is my first lowest y value, and then everything up above it, I could find, you know, two places if I wanted to put my finger. So we say that the range is any y values -4 or higher. Okay? So this is the square root function. We're going to do the same thing. The domain, we want to think left to right. So left to right, am I restricted? And I am. Right here is the smallest x value that I could have. So -2 or anything above. So I'm going to illustrate that, a bracket, because my graph is on -2. So these are the x's that I'm allowed to plug in. What are the y's that I get out? Think up and down. Now, whoops, sorry, that should be a D. Be careful. Y is 2, I could put my finger there. If y were 5, I could come out here and find a place. What's the lowest y value that I have? Well, it's here at 0. It's 0 or higher are the y values that I would get out. Okay, so this is a total visual thing. You just got to see a lot of examples. Here's another one. Now here's something called an asymptote that you might not have heard before. I'm going to use this green line to accentuate this axis. This graph looks like it's getting really, really close, but this is a graph of an exponential, and it actually has an asymptote. It gets really close to 0, but it never touches it. So 0 is acting as an asymptote here. Okay, so we're going to need to remember that when we do our range. But our domain, if I think left to right, every x value I would want to try, granted that I extend the picture, I could find a place to put my finger. So every x number would work here, all real numbers. So do the infinity thing. But my range, up and down, I kind of hit this roadblock here at this asymptote. My graph almost touches at y equals 0, somewhere back here. But since it's an asymptote and it never touches right on, I'm going to put a parenthesis around 0. Okay, I don't want a bracket because it never actually gets to it. But any number higher than y, I also would get as an output. Okay? So here's another kind of same idea. Let me accentuate the asymptote again. Here it's happening vertically. It looks like it's getting really close to 0 again, but it's not going to touch. And this time this is going to affect my domain, because when I'm thinking left to right, it looks like my graph will come close to a 0 here. Obviously, I don't go to the negatives. It looks like I might get to 0. I get really close, but I never touch because of the asymptote. So I'm going to put a parenthesis. And then obviously, I've got from almost 0 to infinity for x values because my graph would keep going. So I could always find a place for my finger at like x equals 5. The range up and down, you know, I don't have any restrictions. Knowing that my graph keeps going down and off to the side, I could always find y values. So I would say all real numbers if I could imagine the extension. Now I know I'm kind of going fast, but I want to show you as many examples as I can. This one, the range would be all real, left to right. If I extended the U shape, I could always find a place to put a finger on the U. However, my range, I bottom out here when y is 0. So at 0 here or higher. So, whoops, sorry, I want a bracket there because it's on 0. So 0 to infinity. Now this is a cool graph. Left to right, if I extended the squiggles, I could always find a place for my finger. However, the range, I have a cap on the top and bottom. I never go below -2, and I never go above +2. So I'm going to put brackets around those since it reaches those numbers. This next one is a cool one. Left to right, so I'm thinking about the domain, I've got this gap here. So at 0 or -1 or +1, I couldn't put my finger on this weird looking graph. I could only put my finger if x's were -2 or smaller, or +2 or bigger. So I'm actually allowed to split up my domain into 2 parts. So a graph representing this left part would be -infinity to -2. Brackets around the -2 because it is on it. And I'm going to join this so we make a union. So we write a U with 2 to +infinity. And again, a bracket because it's on the 2. So remember, this is going left to right. Now up and down, what's my restriction? Well, up and down, the lowest I ever get is at 0 here, or I have y values that are greater. So bracket 0 to infinity. Okay? Here's a cool one, an oval shape. This is actually easy, one of the easiest of all. Left to right, you're kind of bound between 2 numbers. You never go past -2, and you never go past +2. So that makes up my domain, -2 to 2. The range, looking up and down, you never go below -4, you never go above +4. So that one was actually a nice one. Here, this W shape is cool. Again, you've got to have an imagination. You've got to realize that this graph keeps going and it is at a slant. It is getting bigger. So if we extended this W past the screen, left or right, I could always find a place. So like out at 100, I could find a place. Obviously, it goes past the screen, like I said. So this guy's domain is all real. Now his range, think about your lowest point. You never get below a -1. So it doesn't matter this little diphthong thing happened in the middle. Your lowest spot is a -1 or anything above it. So that would identify my range. A couple more I want to show you, and then I'll probably run out of time here. This guy, it doesn't matter if you look at the bottom or the top part for the domain, so left to right. If you extend the V, you'll always have a place for your finger. However, his range, we've got to split it up. So, up or down. You know, you've got this part and you've got this part, but then you've got this hole in the middle that you can't include. So, his range would be -infinity to -1, representing this bottom part, and we would join it with this upper part. 1 to positive infinity. Okay, so I'm about to run out of time, so I've got to stop here. So keep learning, guys, and I'll have fun. I'll see you next time.